Good evening all. Alright, so last lecture for the day. Where were we in the last class?
Important definitions, focus.
Acha, we had started so which important definition we stopped at?
Second focus.
Principal axis. Did I define what is principal axis?
Yeah.
Focus is defined. First and second focus. Excellent. Sure. So Okay. So now today we'll discuss image formation, right? Switch off. So the technique is you have to cover it like this. Okay? So then it doesn't go there. Cover it like this. Is it gone?
Yes.
See, so simple. Small technique. So what I did is reflection of electromagnetic waves. Viola. This is what has happened. Reflection, right? Because if you cover it and press the button, nothing will happen. See? Physics. Okay? It works. So now, image formation. Use it down. Image formation by convex lens. So, we'll study the ray diagrams for image formation. So, ray diagrams. For image formation for various object positions. Okay. So, the first is object at infinity. So we will see the ray diagram for image formation for object at infinity, right? Which lens we are taking? Convex. Okay. So the way you will draw the ray diagram is first you will draw the horizontal line, which will represent your principal axis. Then on that line you mark O, which is the optical center of the lens. Then draw this straight line, right? And then convex lens looks like this. So see the process. First the cross, horizontal and this, and then the curvature. So O is the optical center of the lens, right? Then you have to mark the focus and the center of curvature on both sides. So at equal distances, the focus and center of curvature. So it is generally F and 2F. So this is 2. For convex, 2 is on the right side and F1 is on the left side. Okay, so you know this. When the object is at infinity, right, then the rays will be parallel to the principal axis. Okay. So for image formation, this is one of the rays you will take. Ray parallel to the principal axis. So take a ray above and below. Okay. Whenever the object is at infinity, the rays will come parallel to the principal axis, right? And then any ray which comes parallel, it passes through focus. We know this. Okay? So you have to remember this. Any ray which is parallel to the principal axis, it passes through focus. And this also will pass through focus. So these two rays are meeting after refraction. Right? So what kind of image will be formed? Real. So what did we get? Image at, when the object is at infinity, then the image is at focus. Okay? For object at infinity, image is formed at focus, right? Size is highly diminished because it is a point size. Highly diminished. So this ray will go further, but where is the image formed? Where it is intersecting at the point. Okay. What is the nature of image? Nature is real and inverted. So remember, what is a real image? Wherever the refracted rays will actually meet, that is the point where the real image will be formed. You must have studied it in case of mirror. Real image is formed where the reflected rays meet, in case of mirror, reflected rays. But here it is not reflected, here it is refracted. So incident ray and the refracted ray, both arrows you have to show. Incident and refracted. Before the lens, it is incident. After the lens, it is refracted. So wherever the refracted rays meet, that is where the real image will form. Okay. So right now, this is the ray diagram for object at infinity. So what are the rays that you take for image formation? One is ray traveling parallel to the principal axis. Other is ray passing through focus and ray passing through optical center. So in this case we don't need, so with this parallel rays itself we got the image. Okay. Second is object beyond 2 f1. बना लिया सबने?
Yes.
Shall we discuss the second one? So again, the horizontal line, the straight line, and the convex lines. Then first focus, first radius of curvature, second focus, second radius of curvature. So radius of curvature is always twice the focal length. Okay. Is everybody ready? First look here. So now the object is beyond 2f1. So when I say beyond, okay, so it is beyond lens, right? The object size you keep less than the lens. So let us call this as AB. So this is our object. So you have to take at least 2 rays for image formation, right? So the first ray you always take parallel to the principal axis. So the ray which travels parallel to the principal axis, we know it will pass through focus. Right? So you have to show the direction before and after refraction. Now what about the second ray? Second ray you will take it passing through optical center. So I know any ray which passes through optical center goes undeviated. Correct? So let's make it pass through. This is here scale. Okay, so where is the image position between F2 and 2F2? So what is the pattern? As the object comes nearer to lens, the image goes away from the focus. So what is the image position? So the first thing is image is formed between F2 and 2F2. So image is formed between F2 and 2F2. So what is the size? What is the size of image?
Smaller than the object.
So diminished. Whenever it is smaller than the object, we say diminished. Third, nature.
Real and inverted.
Yes. Real and inverted. So see, here the image was highly diminished because it was point sized, but here it is little bigger, but still smaller than this. So it is diminished. So if you draw these points proportionately, you will get this image size big or small, okay? Like this F1O should be equal to F2O. 2F1O should be equal to 2F2O. So these lengths should be equidistant on both sides. Then you'll get the diagram proportionate. So all of you have drawn the first diagram. So how many object positions are possible? So we saw infinity, like infinity was very far away, then beyond 2f, second, third is at 2f, fourth is between 2f and fifth is at f1, sixth is between f1 and 1. So only 6 object positions. That's very simple. क्या हुआ? डायग्राम नहीं बन रहा. डायग्राम बन गया. So arrow कौन बनाएगा? Without arrow, diagram is nothing. Arrow before and after reflection. Everybody. There should be every ray should have at least 2 arrows. And the diagram should be labeled. Here also no arrow. Okay, it's wrong. Okay. Arrow. एरो दिखाओ. तो वेव बना दिया. व्हाट हैपेंड? अरे ये लगा तुम बना रहे हो तो यू आर शेकिंग योर माइंड. ऐसे नहीं चलेगा भाई. ठीक. So you have to draw the rays carefully. Okay, third. Where is the object now? So, what is the expected image now? Size? So, it will form at 2f2. It will be further pushed. So, whenever the object is at curvature, you obtain the image of same size. Okay? So, horizontal line. Then we have this. So you label it later, okay? First you draw the rays. So where is the object now? Here. First ray parallel. It will pass through focus. Right? Now where is the image? Image should be here. This point, okay? This is how you should get correct area. Now match this point, and this point. Okay, so this is not. Now you can label. So this is your F2. This is 2F. Right. So just write here A. This will be A dash. Now arrow. So image at F2. Same size. Hmm?
B. We are not labeled B.
This is 2F1. No?
Yeah.
What is given in the book? You have labeled? ठीक है तो लिख दो B. ठीक है, you can write B here above. So here also you can write B, B dash. That's fine. See, main is this. So we parallelly we should mention use also, right? So what is the use of this? It will be used in cameras, right? What is the use of the second? Camera lens. Used as camera lens. Okay. And the object is not very far because it is just beyond 2F. Yeah. Object is not very far. Likewise here. So what was the use for the first case? What is happening in the first case? All the rays are concentrated at one point. So it can be used as a burning glass. Right? Burning glass.
Solar cooker.
Solar cooker में हम mirror use करते हैं. We don't use lens. Okay? So it can be used as burning glass. For the first one. This is third one. But for the first one you write in your notebook, use. Used as a burning glass. What about third one? Use a slide projector, right? Or telescope. In this manner, convex lens is used in telescope. It is used in
So what was the first one?
burning glass. Third is used in telescope. To erect the inverted image. See, what happens is in telescope you will be getting a inverted image and use one more concave lens. So here the object is inverted, so what you will see is upright. Okay, so whenever you get the inverted image, use one convex lens again. So this is how it is. Okay. Because real images are always inverted. To make it upright, use one more. Fourth now. What is fourth? What is the object position now?
Between 2F and F1.
Yes. So object between 2F1 and F1. Pen चाहिए था black. Hello? Black pen देना था. So So right side you don't mark, you just mark and don't write it, okay? First draw the diagram. So this is your 2F1, F1, here we have F2, okay. Let's say you have AB. So first will be parallel. It will always pass through the focus. Where do you expect the image?
After 2F.
Yes, after 2F2, right? It is going on away, right? So where will it? So now join these 2 points. And you have to make sure that it meets after this point, okay? So the rays are meeting after refraction. So what is the nature of image?
Real and imaginary.
Yeah, so image at image beyond 2F2. Size is magnified, right? Magnified. So now image is going away and its size is increasing. So it is as per the expected pattern. And it is real and inverted. So what is the use? It can be used in cinema, right? Because it is, you must have seen, no, in cinema hall, the lens or the projector is above your head and the screen is below. So when the images are inverted here itself, then you will see it on the screen upright. Okay? So this is the use. Application. Convex lens is used in cinema and slide projector. Cinema and slide projectors. Right? So the film is kept inverted here so that you get the erect image behind the lens. And it is also magnified. Okay, so 2 more positions are left. You had written this, no? So we have fifth. Object at F1. Now let's see. always beating the object. So object is now at F1. So first ray as usual parallel to principal axis. So it will pass through F2. Right. Now what about the ray passing through O? It will not deviate. So are the rays parallel?
Yes.
They are parallel. So it will meet at infinity. So where will be the image formed? Wherever they will meet. So where will the image be formed? Okay, so I'm saying it will meet at infinity. So image at infinity. Right. Size so where is infinity? Where is it? Where is the principal axis? What is the size? Highly magnified. So it's reverse. When the rays were parallel, it was highly diminished. Now when where was the image formed? At focus. But now when the object is at focus, the image is at infinity. So there is a pattern. Okay, when object is at focus, image at infinity, so it will be highly magnified, no? With respect to this line. You don't know where it is meeting. But we are assuming it is meeting. So any image which forms behind the lens is always real and inverted. Remember this, whenever the image is behind the lens, it will always be real and inverted. Okay? So for virtual, it has to be in front of the lens. Same side as object. It is opposite to mirror. In mirror, in case of reflecting mirror, the virtual mirror, the virtual image is behind the mirror, right? Because reflected rays will be always in front. Okay? So all the real images in case of reflecting mirrors were in front of the mirror. Only virtual was behind. In this case, it is opposite. All real will be behind, only virtual will be in front. Okay, this is a difference between image formation in case of lens and still a lot of time. 20 minutes. So what is the use? Used as collimator in spectrometer, right? So the parallel beam of rays. So what is the use given? Collimator of a spectrometer. What is collimator? So collimator means rays are parallel set of rays. So we will input this into spectrometer to analyze the rays. Okay? So right now you understand collimator is a device which will produce parallel beam of rays. So used as collimator. That is parallel set of beams. Parallel rays. Used as collimator of A spectrometer is a device which is used to analyze the incoming incident ray. Okay, so it will give you a graph telling what is the wavelength, what is the intensity, all those things. But we did not go into the details of this. Now the last one is, has everybody written this? So we did till F1. Now what is left between F1 and O? Okay, between F1 and O. So since this object F1 and O. So straight line, principal axis, then cross, and so it should be symmetry, right? This should be perfect curvature on both sides. Yeah, one. Yeah, one. Now the object is between focus and optical center. So as always, we will go through the focus. And the other one will go through the optical center. What is happening to the rays? After diffraction, they are diverging. Are they parallel? Diverging, right? So whenever they are diverging, what we will do? We will extend it backwards. Straight line. This also has to be extended backwards. So where are we meeting? Image will be formed here. Right. Okay. So is this clear? Yeah. So what is the image?
Question.
Yes. Image in front of lens. Of lens. Okay, so you just write front of lens. Then it is magnified. Behind the object. Front of lens behind, beyond the object. So this distance is beyond, okay? Away from the lens, right? So how you measure distances? You always measure distances from O. So beyond object will be away from the lens. That's what we are saying. Image in front of the lens beyond the object. So it will be away. Magnified. And it is virtual and direct. Right. What is the use? Magnifying glass. So if you get the logic, it's not difficult. But you'll have to practice to get the ray diagrams correct. Only thing is you have to maintain these distances as equal distances from O. Then it will be correct. Okay, so we have discussed image formation for convex lens for all object positions. We still have 10 minutes, so we'll discuss the image formation by diverging lens as well. It has only two object positions. Okay? For concave lens, there are only two object positions. Can I erase this side, left side?
Yeah.
Anybody has any question? Object at grade. So let me know when you are done with convex lens. बहुत ज़्यादा चपटा हो गया नहीं वो तो अंदर ही करना है लेंस क्या करो तुम पहले वो लिख दो गेट द आइडिया कि कितना मोटा लेंस है So now in this case the object is at infinity. क्या होना चाहिए? Let parallel max. ठीक है और इसका in case of concave lens these are f2. Right? So it will diverge away from F2, right? So where will it get focused? So when the object is at infinity, image is at ठीक है कॉन्वेक्स लेंस में कहाँ बना था राइट साइड में बना so just keep this in mind this will be 2 here what is the size point size highly diminished so this diverge these rays appear to be diverging from this point, right? What is the nature of image? Image at f2 in front of lens. So front में कैसा रहता है? Virtual. Real काम होता है behind. So virtual. वर्चुअल कैसा होता है हमेशा डायरेक्ट होता है रियल कैसा होता है हमेशा वर्चुअल एंड डायरेक्ट डायरेक्ट sometimes is also mentioned as upright or upright ठीक है where is it used it is used in Galilean telescope. Used in Galilean. The spelling correct. Galilean, correct. Galilean telescope. So in the Galilean telescope, the image is upright itself. So it's a small telescope, right? Whereas the big terrestrial telescope, right, the image will be inverted and use one more convex lens upright. So here the image is upright by default, but it looks small. Next object position is anywhere beyond optical center. Okay, so next object position is any finite distance from the convex lens. Right? Object at any finite distance. Okay, so it could be anywhere. Just keep anywhere you can. So then what do you have? Focuses. So let us say I am keeping the object. Straight, then it will diverge away from the focus. second ray we will take from the optical ray. Go undeviated. Right, so when I extend it backwards, okay, where is it meeting? There. So this is A dash, B dash. Got it? So parallel ray goes away from the focus, and this will go undeviated. So when I bring it back, it meets this ray over here. So what is the image? It's image between optical center and F2. Correct? Where is the image? Image is between the lens and the focus on the image between O and F2 in front of lens. So always mention front and behind so that you have the idea of nature of image. And now it is diminished, right? Smaller than the object, diminished. Here it is, virtual and direct. Using spectacles. घंटी बहुत डरावनी है नहीं सर में ऐसा जैसे ड्रिल कर रहा हूँ ऐसा somebody is drilling your head used in spectacles to correct to cure what do we cure using diverging lens हाँ myopia दूर का ऑब्जेक्ट नहीं दिखता अपने को so to give myopia, right? Short-sightedness. Near objects are seen clearly, but far away objects are not seen clearly. Okay? So when we see far away objects, the image forms in front of retina. So to push the image back, we need to diverge the incoming rays. So then the image will form at retina. All right, so short sighted. The other name for myopia is short sightedness. All right, so let's meet in the next class. Good night, everyone.
बारिश नहीं है ना
Sir, it is also. No.